200 Years of IT. A fairy tale about usefulness, limitations, user interfaces, processes, and you. The story of IT over a period of 200 years can be told as a fairy tale. 200 years may sound like too much, but we are extending the story a bit into the future. It may be a fairy tale. It might also be a can of worms that we are opening. I'll leave that decision to you. So let us begin as all fairy tales should begin. Once upon a time. A fairy tale often circles around the princess. This lady looks like a princess on this painting, but some of you may recognize her. She is Ada, Countess of Lovelace, the daughter of the poet Lord George Byron. She was the first computer programmer in the world and probably the only one that never copied the program from somebody else. So you might guess who this is. This is not a prince either. It is George Babbage, who designed the first computer in 1822, almost 200 years ago. It was not a kingdom, but probably much more than that. This thing is definitely big iron, and it is housed in a frame. Babbage only built parts of the machine himself, so this copy is built much later from his original design.
So let's just watch it work and then we'll talk about it. Go ahead. Why don't you just rotate slowly around clockwise direction?
Has everybody got a chance to see both sides?
No, go ahead. Let's change.
More advanced machines, but they were never built in his lifetime. So the princess had to sleep for 100 years. Experimental machines were built in the 1930s, and working machines in the 1940s, but let us skip quickly to 1951 and EDSIC, the electronic delay storage automatic calculator.
The mathematician explains his problem function. A member of the RAPS to point out that there is a more suitable routine available. A read routine and a print routine. The committee proceeds to discuss the problem. That's to work, referring to the catalogue as program sheet. Is now checked and it is ready for punching. This is Margaret Hardy at the time. She is of punching and at the moment she will go at one of the library tapes. She copies mechanically onto the tape she is preparing. She takes it to the computer room, attaches a tape ticket and puts it on the job. Takes our program tape and puts photoelectric tape reader. The instructions are being read, going into the store. Results are coming out. Our programmer collects his results. He is joined by a politician, apparently all.
Before we leave the past, please take a moment to consider these questions. What were the usefulness, the limitations, the user interfaces, the processes, and the role of people like yourself back then? This could be part of the answer. Computers were used for mathematics and for administrative use. They were standalone machines, and the user interface hardly existed. Processes were primitive, and you were expected to wear a white laboratory coats. There used to be many brands of mainframe computers. They popped up in the 50s, 60s, and 70s. Are there any of these that you don't remember? But competition was tough, and one by one they merged or folded. So now there is only one of them left. So the fairy tale continued to be told. Do you remember this Norwegian troll who is visiting the valley of his parents in this photo? Yes, that was Jin Amdahl, the chief architect of the IBM 360 mainframe. This princess you must surely remember. Hopper, the mother of COBOL. This prince might be a bit more difficult in an audience like this one. He was co-founder of the company that was the Apple of the 1960s, called Fairchild Semiconductors. Bob Noyce, who created the processes that made transistor mass production possible when he was leading Fairchild Semiconductors. After that he co-founded Intel and led the invention of the microprocessor. About what the world would look like without microprocessors. There would probably not be energy enough to run AZ-13. There would be no space travel. There would be no mobile devices. No cell phones either. And there would be no internet. Time has passed since 1951, not to mention 1822. Today IT plays an enormous role in society and economy. It brings so many possibilities. The angels of Raphael in the picture are dreaming about solving our problems and making the world a better place. He also has a proportional part of downsides. This picture by Bosch shows the purgatory, where both the gates of heaven and hell are open. IT is part of the general picture of our production, our economy, and our government. We will consider both sides in this discussion. In my opinion, the greatest challenge to mankind today is the climate changes. These changes are creating or influencing all the other challenges we meet today. IT has the ability to help us solve or alleviate a lot of the climate problems. also adds a lot of load to them. These are some of the positive examples where IT is helpful. Maersk Line used to have specialists to manage the load of their ships based on knowledge of routes, contents and processes. This was helpful both for their economy and for their carbon dioxide footprint. They are retiring now, but their skills have been taken over and improved by analytics. United Parcel Service is reducing their carbon dioxide emissions by planning drivers' routes to take more right turns than left turns. Simple, but efficient. In many big cities, traffic is being monitored continuously, and work is being done to try to reroute traffic from congested routes. This will both save time for the individual drivers and reduces the emission from cars stopping and starting in queues. The relocation of data centers to cooler areas with access to renewable energy sources and the consolidation of servers to more efficient hardware also can help reduce emissions. The next big issue is economy. IT has been a driving force in shaping economy over the last 30 to 40 years. It has even greater potential in the future. But politics, governments, and the international community is lagging far behind in updating the regulations and balances that most people in the Nordics find necessary. The balance between economy and democracy is tilting in a troublesome direction. And IT is central in making this possible. Bursting IT bubbles have been an important factor in world economy, and bubbles have been part of the picture since 1987. Interestingly enough, mainframes have been evolving quietly and almost unobserved, doing all the heavy work, while bubbles have grown and burst in other sectors of the industry. Currently there is a discussion whether social media are a bubble or not, and whether it might burst. Google and Facebook are making loads of money, but a number of other big players show the usual picture of big investments, volatile stock prices, and no income at all. If this is a bubble, and if it is going to burst, it is difficult to predict whether it will have a similar impact to economy as earlier bubbles. On a much larger scale, prominent thinkers like Klaus Schwab is discussing the transformation of economy and society. He claims that the speed, the scope, and the impact that IT has on the economy makes it reasonable to talk about a fourth industrial revolution. He sees a separation of the job market as one of the consequences. At one end we have highly skilled workers in a privileged situation. At the other end the traditional Western middle class is being pushed downwards and out. This is a trend that we also see in IT, and we feel it deeply in the mainframe area too. The tendency among mainframe people in the Nordic area seems to be the same. While general IT unemployment has been steadily falling the last few years, we see our jobs being sent in different directions. Highly skilled jobs are hit by a whole generation going into retirement. At last employers have started to recruit and train young successors to us, but they see the need to call retired employees back on part-time or short-time contracts. And both less skilled and some high-skilled jobs are being offshored and nearshored with varying degrees of success. Operations staff is probably hit hardest by often nearshoring. But also developers as well as systems programmers are facing the split and the offshoring. A brand new trend, based on IT, is called the sharing economy. This is the hype slide, and I won't try to read it load for you. They are creating a brand new language for it, and it sure sounds impressive. The downsides are described here with a quotation from a recent article in Harvard Business Review. The authors of the article don't consider it as sharing, but as a brokered access to someone else's goods and services. The premier examples like Uber and Airbnb does not look anywhere near a hippie dream. The owners have become billionaires, and the employees are not even recognized as employees. They do not have the rights and security and employee needs from a Nordic point of view. Instead, the companies are breaking or bending many laws in Europe. And when police, courts and governments try to constrain them, they mobilize their employees as a political force for their own purpose. We have seen that in New York, where Uber used its app to get employees and customers to put political pressure on Mayor Bill de Blasio. One of the strongest growth areas in IT is healthcare and caring for the aged. This is an area which has strong roots in the mainframe area of the genome of humans, other animals, and plants have been going on for a number of years, often using analytical technologies like IBM's Watson. This is the basis of the CRISPR technology that is now being used to edit DNA. It has big possibilities for new cures, but also creates ethical concerns and new aspects of the discussion of GMO. This has also become part of the current transatlantic trade negotiations. Another new area is 3D bioprinting. Companies like Organovo are developing tools and methods, which has the promise of 3D printing of human organs for transplantation. Currently they are printing tissue, so this picture is still future, but it is rapidly becoming a real possibility. On the other hand, mechanical prosthetics like arms, legs, and exoskeletons are very much part of the present. They are connected to the nervous and muscle system of the patient with amazing results already. And robots in healthcare and in caring for the aging is an area in fast development. One interesting area of research is related to better understanding not only the human language, but also the 90% of communications beyond the spoken words. The task becomes more manageable when you break it down into smaller building blocks. The 7,000 languages of the world consist of only 800 phonemes, which is the building blocks of sound. And current research and experiments are trying to classify moods into 14 categories. This yields a limited number of combinations, which analytical code is hoped to translate into writing. So they are working on software modules in various areas. Extending face recognition to facial cues is one. Analyzing images is another. What Pascal Fung and her team is working on is an empathetic robot. If they will succeed in a reasonable degree in doing this, they certainly can make robots much better aids. But it in healthcare and in caring for the aging. But the technologies raises two questions. One is where the limits are in reality and the consequences of misinterpretations. The other is the privacy concerns about surveillance and control. In any case, RoboCare is already part of the present, and it seems to yield very good results. The robot discussion has led us far into the discussion of new user interfaces. As some of you might remember, we traveled a long way from the early mainframe interfaces like teletype and terminals to the first distributed clients. And then we went on to all kinds of mobile devices and wearables. Arthur C. Clarke once said that any sufficiently advanced technology is indistinguishable from magic. So let us see some of what is coming next.
I'm a huge Star Wars fan, and I distinctly remember watching the Star Wars film where Yoda brings the X-Wing out of the water, and I spent probably far too long than I'd like to admit staring at cars to see if I could move them. So to have that ability to control my own The Force in this instance, that's very cool. My name is Joshua Carr, and I am the technical liaison for IBM's Worldwide Bluemix. I'm always curious about the technology that's coming up, what's next. And recently, the headset that allows consumers essentially to read their own brain and understand what's going on inside your head was successfully funded, and I had the opportunity to get hold of one of the first that were shipped. The headset itself uses known technologies to look for specific markers, things like excitement and interest. What we can do is train our headset to recognize certain familiar commands that we think, and the device learns essentially that this means action A. Then we can send that data via Bluetooth off to the internet. But once it's there, what do we do with the data? There's an awful lot going on in my brain, I hope, and what can we do with that? And that's where IBM technology comes in. We process that data, we flow it through, and we make meaningful interactions using small amounts of code. So in this instance, what I'm doing is using a command and translating that into a push movement. I used the Java SDK that came with the Emotive Insight and the Java Internet of Things Foundation library, and essentially combine them together to publish the data to my Internet of Things service that sits on Bluemix. And I spun up a boilerplate that uses Node.js, and on top of that sits Node-RED, which is a wiring tool for the Internet of Things that allows you to easily and efficiently take data and run functions against it, sometimes with code and sometimes without having to explicitly write the code itself. In the films, they talk about the Force binding people together. In the near future, we're going to take a huge leap in feeling truly connected with other people. And for me, it was such an easy step to think about how can I use my brain to control robots around me. If I could make any technology from Star Wars real, it would not be lightsabers. Can you imagine giving a lightsaber to somebody? The first thing they would do is chop their arm off. Let's take baby steps. First, faster than light spaceships, and then lightsabers. Once we can prove that we're not going to destroy the universe with spaceships, then maybe we can deserve lightsabers.
Much of this new stuff is on the surface of our systems and in the user interfaces. But as mainframe people, we know that most of the important processing is still happening in our machine rooms with really powerful machines. We have seen user interfaces change rapidly over time. This one worked very well over a long period of time. Infrastructure was easy to understand, and the separation of duties were simple: an input operator, a systems operator, and an output operator. Having terminals and online access brought computing to many more users, and it's expanded its usefulness immensely. Infrastructure added telecommunication and various controllers, and soon we added connections to other systems using APPC and later MQ. So we added the network specialists and network operators to the staff. Microprocessor revolution added client-server and web browser interfaces. Many more users were added. Much more functionality came into play. Comes those microprocessors again popping in to ruin the nice, simple picture. Personal computers and laptops were connected using TCP/IP. New types of network components were added. Network security became a big issue. And the user interface design moved to new teams who often never even knew that there was a mainframe sitting behind their user interfaces. We have to ask ourselves this question: did we connect to all these new types of colleagues? Or did we just sit quietly back, hoping it would go away like a flu? Of course. Sometimes we thought that the graphical user interfaces were not always easier to use than the traditional interfaces. We know that the web was only the beginning. Mobile interfaces are everywhere. And they are already only a fraction of the automated input devices of the Internet of Things. It is obvious that we cannot hide in our glass houses. We need partners in other areas. And we need help. And still this I just talking about the front-end interfaces. The back end is also growing very quickly in complexity. We are coding outgoing service calls using MQ, IMS Connect, and web services for CICS. We are connecting to all kinds of other systems. On the ground, or in the cloud. And we often have to spend a lot of time to make systems talk to each other. Again, can we do more to connect to the people designing, building and managing the other components? In this conference you will hear a lot about cognitive, analytics, big data and other evolving areas. People tend to run them on distributed systems, but we also have the possibility to run them on a Z platform. And, even more interesting, we can create hybrid applications joining the new application types with our existing transaction and database systems. We had a very interesting presentation at the Helsinki GSE conference 3 years ago. The speakers demonstrated how to set up such applications and gave some examples of their usage. They showed how warehousing and banking systems can be extended to such new types of applications on the Z platform. This is a slide from their presentation. It shows an application running on a Z system with accelerators. Structured and unstructured data is fed into a data warehouse. A transaction enters the system and goes off to analyze whether the transaction should be completed according to the information in the data warehouse. Analytic and cognitive systems like Cognos and SPSS does the analysis and returns the result to the main transaction. This model can be used for many different purposes. But for mainframe systems to continue to play an important part in IT, we need more than hybrid applications. We also need hybrid thinking to match. There are some kinds of user expectations like response times and stability where we must share our knowledge and experiences with our colleagues. And there are other kinds where we should admit that we have a lot to learn from our colleagues. This requires an openness from both sides. It also requires ways and means to communicate and understand each other better. This is a cultural and an organization issue. But we must face it and solve it. Otherwise our fairy tale might not get a happy ending. Besides organizations and culture, we have a lot of work to do in converging the tools and methods we are using. You might be a world champion in using Teaspoon and ISPF. Perhaps even your father or grandfather was. Or perhaps you prefer even more traditional user interfaces? I am sure we can still find some paper tape to punch somewhere. But you might admit that there are a lot of new tools that can make our jobs easier, more efficient, and even more fun. These tools can also help us bridge the gap between mainframe and distributed people. This slide uses Rational products as examples, but there are many similar tools from other vendors. Let us return for a moment to reconsider usefulness, limitations, user interfaces, processes, and your own roles. It can hardly compare to what we discussed about the past. IT is everywhere now. You can connect from almost anywhere the people live and work. The user interfaces have become much more intuitive for people outside IT. The processes have become very complicated, and you need a computer to run a computer. And the roles are changing. A lot of people present here have changed roles, titles, and even companies so many times they can hardly remember them all. That should be food for thought for what will happen in the future. Now, a discussion about IT at present and in the future would not be complete without discussing privacy. These American gentlemen seem to disagree about liberty and privacy. The IT kings think that our privacy is an illusion, and furthermore irrelevant. Benjamin Franklin said something quite different, when he said that those who would give up essential liberty, to purchase a little temporary safety, deserve neither liberty nor safety. In old Eastern Europe, Stasi and KGB would probably agree better with McNeely and Ellison than with Franklin. The changes in the world are accelerated by climate changes and economical changes. These changes impact wars, acts of terror, and migration all over the planet. This is used on an almost daily basis as an argument for major changes in law and enforcement. And again, IT plays a major role. The problems we are facing are used as an excuse to sacrifice privacy for the normal, law-abiding citizen. But also the drive to make our companies still more efficient drives such reductions of privacy. Here we see a new set of technologies invading the workplace. This is a set of wearable products that are intended to hang on to you wherever you go and whatever you do at work. Can you imagine every visit to the restroom being stored in the cloud? As they say, managers can proactively understand disruptions, and senior leadership can understand the behavior profiles. I don't think I would want to work in a company that took sociometry to such extents. Data is exploding. We are suffering from severe information overload. And it happens from all sides, with data of all kinds, in a magnitude nobody could have expected, back in the EDSIC days. Data has always been a major asset of human beings. We have worked hard to take the implicit data that is stored in our minds and refine them into data, information, knowledge, and perhaps even insight. All the steps up through this pyramid can now be computer-assisted. We were shown at the closing keynote in the Tallinn GSE conference in 2010 how to use social media to turn implicit data into unstructured data. Watson and the technologies connected to it can turn unstructured data into structured data. Cognitive and analytical software can combine this and all the existing structured data into information. And in the future we will hopefully progress towards knowledge and insight. This could be very enriching for mankind. But all this information can be abused by all kinds of parties, both official and criminal. Many dictatorships are using IT to do the same kind of work much more efficiently. And leaks like the ones of Edward Snowden has shown us that it also happens in democracies. I will share with you a trailer of a current American TV series on the subject.
You are being watched. The government has a secret system, a machine. It spies on you every hour of every day. I know because I built it. I designed the machine to detect acts of terror, but it sees everything. Violent crimes involving ordinary people, people like you. Crimes the government considered irrelevant. They wouldn't act, so I decided I would. But I needed a partner, someone with the skills to intervene. Hunted by the authorities, we work in secret. You'll never find us. But victim or perpetrator, if your number's up, we'll find you.
One thing is data about people. The Internet of Things is producing data in orders of magnitude above what we humans can. And the security problems are also growing in this area. Here is an electric kettle that leaks your Wi-Fi passwords while boiling your water. All in the same process, and without having to ask you. So let us wind the discussion up by taking a last step into the future. Internet-connected toothbrushes and self-driving cars are not even future anymore. Let us see what Google presented this spring.
The Dutch cycle more than any other nation in the world, almost 900 kilometers per person. But that also means we have 350,000 bike-related injuries. Now imagine that we would make biking safer, smarter and easier by applying self-driving technology to biking.
We taught our self-driving bike to figure out where it is, what's around it, what will happen next, and what it should do. We leaned on Google's expertise in self-driving cars, but we had to adapt the technology to work on a bike. We decided to add 2 additional features. First, you can request the bike to pick you up wherever you are, and we developed a comfort mode, adjusting the pedals to a perfect resting position.
I think the self-riding bike could really give a boost to the economy because people could also work on their bicycle. You work in your office, you work in your home, you work in your car. You could even work on your bike.
I have so much more time. My kids love it. They're just free. They can go anywhere they want, anytime they want. It's amazing.
At the Fietsersbond, we feel that this is the biggest invention since the invention of the bicycle itself.
At Google, we always put our users first. With the launch of this bike, we believe we do that again.
Please enjoy the conference. And if we are going to have a happy ending, then please remember what GSE is all about. Give and take.